Greetings, our dear candidates of Global Junior School. I would like to welcome you to this science lesson. I'm Johnny Korat, going to take you through today's lesson. But to begin with, we are going to revisit our previous lesson. Yes, can somebody remind us what we looked at in that previous lesson? Okay. Yes, we basically looked at the law of levers, or we can also call it the principle of moments. Okay? Yes, what did we say the principle of moments states, or the law of levers states? What does it state exactly? Okay, we had two alternatives, remember? Yes, we said that the law of levers, or the principle of moments, states that the sum of clockwise moments about any point is equal to the sum of anti-clockwise moments. That is one. Then we also said that the load multiplied by the load arm is equal to the effort multiplied by the effort arm. That is what we said under the principle of moments. So during that lesson, we had some calculations. Those calculations were basically involving the law of moments, or the law of levers. Now, dear candidates, I want you to remember one thing. We said that a moment is a turning force of a machine. However, if you don't say a moment is the turning force of a machine, we can also say that a moment is the turning effect of force. A moment is the turning effect of force on a machine. Now, when you look at machines, especially levers, there is that tendency of a lever turning. That turning effect of that lever is what we call a moment, okay? Usually, when we are talking about levers, or when we are talking about the principle of moments, I want you to put something in your mind. There are forces that are involved. Now, those forces are the ones that cause that tendency of a machine turning, okay? What do we call the turning point of a lever? Yes, we call that the pivot, or the fulcrum, okay? Now, when we are dealing with these calculations, we need to specifically deal with the load, which is a force, and the effort, which is also a force. Now, because the load and the effort are forces, we use units. Which units do we use? We can use the units called newtons, okay? If we don't use the units called newtons, we can use the units that we call kilogram force. Are we together, dear candidates? Yes, I would like you to sit upright and learn this today. Now, today we are going to continue with more calculations involving the law of levers, or more calculations involving the principle of moments. You remember the principle of moments very well. Now, let us look at here. We are going to look at our examples, and we want to look at our example 1. But before we go to that example 1, I want you to know that today we are going to do calculations that are involving two forces on one side and one force on the other side, or two forces on either sides of a lever, okay? Two forces balancing on either sides of a lever. Let us look at our example number 1. It just says find the value of x. Find the value of x. And that is our diagram. You can see that on this side here. On one side of that lever, there is a force of 15 kilograms. That force is placed a distance of 4 meters away from the pivot, okay? And then on the other side, we have another force. And that force is 5 kilogram force, which is placed 2 meters away from the fulcrum or away from the pivot. And then we have 10 kilogram force, which is placed x meters plus 2 away from the pivot. So you discover that from the pivot or from the fulcrum to the 10 kilogram force, there is this distance of 2 meters and x what? Meters. So when you add the 2 meters, when you add the 2 meters from 5 kilogram force, then the x meters, you will get the total distance of this 10 kilogram force from the fulcrum. Therefore, dear candidates, we would like to attempt this number, but how are we attempting it? Let us go to the solution. We are going to follow the principle of moments or the law of levers, which states that the product of the load and the load arm is equal to the product of the effort and the effort arm. That means that when we multiply this arm, 15 kilogram force, by 4 meters, and then we multiply this and this, that's 5 kilogram force and 2 meters. Then we also multiply 10 kilogram force and then x meters plus 2 meters. We shall be able to get the same what? Answer. They should be balanced. Are we together? Therefore, let us attempt. In this question, we are basically asked to find the value of x. X, we don't know it, and we want to find it. Now, what do? We use our principle of moment, so our law of levers, which says that the load arm multiplied by the load force is equal to the effort arm multiplied by the effort force. That is exactly. Now, on this, on one side of that lever, there is 15 kilogram force. So we are going to multiply 15 kilogram force by 4 meters. Okay? And this is what will happen. We shall multiply 15 kilogram force by 4 meters. Okay? And that will be equal to the total product or the total sum of the moments on the other side of that lever. What does that mean? We shall also get this 5 kilogram force and multiply it by 2 meters. Okay? The very way we have done it here in this part here. You can see 5 kilogram force times 2 meters. Then, after multiplying this and this, we shall now add the product of this and this distance from here up to the pivot. But remember, the distance from here up to the pivot, from this point up to the pivot, is got by adding 2 meters plus x meters. Are we together, dear candidates? Therefore, we shall say plus 10 kilogram force in brackets. In brackets, we shall add 2 meters plus x meters. What will be our next step? We shall now remove the units for us to be able to do our calculation easily without being disturbed by those units. So we shall say 15 times 4, which is this, times this, to be equal to 5 times 2, which is this 5 kilogram force, the 5 kilogram force here by this, okay? Now, plus, because this and this are on one side, so we shall add the product of this and this plus. So that's why we are bringing this plus. Now, when we look at this 10 kilogram force, it multiplies everything in these brackets here. So we shall say 10 kilogram force times 2 plus 10 kilogram force times what? X. That's why we shall end up having that. We shall have 10 times 2 plus 10 times x. How did we come to this step? we multiply 10 kilograms by 10 kilogram force by everything in the brackets. Why do we multiply it by everything in the brackets? Because this x is not known. If this x was known, for example, if it was like 3, we would first add this, we would first deal with the brackets, then we multiply what we have got with this 10. Are we together? So after that, what shall we have? 15 times 4, we get 60. And then we shall say that will be equal to 5 times 2, we shall get 10, plus 10 times 2, we shall get 20, plus 10 times x, what do you get? Yes, we get 10x, like that. Now, after that, we can now collect like terms. But before we collect like terms, let's first go to the next step. Shall say 60 will be equal to 10 plus 20, what do we get? We get 30. Then plus our 10x. Now, there we shall now collect like terms by saying, because we have to remove this 30 from this side so that we remain with only 10x. That's why we shall say we subtract 30 on both the sides. 60 minus 30, and then 30 minus 30 plus 10 what? X. That means that we shall remain this side with 30 to be equal to, when you subtract 30 minus 30, you remain with nothing. You remain with a zero. Therefore, we shall remain here with 10x. What do we do from that step, dear candidates? So, from that step, dear candidates, we shall now divide both the sides. We shall divide both the sides by 10. That's why we say here 10x out of 10. Then 30 out of 10. From there, we can now cancel. By 10, we get 1. 10, 1. Let's cancel all. Now, by 10, you get 1. 10 also by 10, you get 1. And then 30 divided by 10. 30 divided by 10, what do you get? We get 3. Therefore, our final answer will be 3 meters. How did we get the 3? We multiplied the 3. We divided this 30 by 10, then we got the 3 meters. Therefore, the distance from this 10 kilogram force up to where there is 5 kilogram force is 3 meters. But now, what is the total distance from 10 kilogram force to the pivot? That means you add the 2 meters plus the x meters, then you get the total distance. Are we together? Let's go to our next example. Example 2 says, Osore, who sits 15 newtons, is balanced by Mark and Ochoma, who weigh 5 newtons and x newtons respectively, as shown on the diagram below. That means Osore, Mark, and Ochoma sat on a seesaw, and they weigh different kilograms. They have different forces. One of them is 15 newtons, the other is 5 newtons, and the other is x newtons. Now, this is our diagram. We shall draw it like this, that if this is Osore, who is weighing 15 newtons, sits 4 meters away from the pivot. Okay? Then Mark on the other side, with 5 newtons, sits 2 meters away from the pivot. Then Ochoma on the other hand will sit x newtons. Ochoma has x newtons seated 3 meters away from Mark. Okay? Now, what does that mean? The total distance from Ochoma to the pivot is got by adding 2 meters plus 3 meters. Okay? Now, how shall we calculate that? We shall still use our law of moments, which says that the load force times the load arm is equal to the effort times the effort arm. Is that okay? Now, what shall we have, dear candidates? Okay, well, sit upright. What is our load? Let Osore be our load, okay? He is having 15 newtons. Now 15 newtons, we shall multiply that by the distance from 15 newtons to the pivot, which is 4 meters. And then that will be equal to 5 newtons for mark times 2 meters, which is the distance of mark from the pivot, plus x newtons for Ochoma in brackets. Now, what is the total distance of Ochoma from the pivot? We shall add the 3 meters and the 2 meters. That's why we opened these brackets and put that inside, okay? Now, after that, we shall now have 15 times 4 to be equal to 5 times 2 plus x times 5. How did we come to this? 5 times 2 plus this. How did we get x times 5? We first dealt with these brackets here. 3 plus 2, what do we get? 5. That's why we said x now times 5, which is this, okay? Then, that will give us a 60 newtons. That will give us 60 newtons. That will give us 60 newtons. So we shall have here our 60 to be equal to 10 plus 5x. How did we get this 5x? We multiplied the 5 times x to get 5x. And then, from that level, we can now go ahead and collect like terms by removing this 10 from this side, so that we remain with only and only 5x. How do we do that? We subtract 10 on both sides because it's a positive. So we say 60 minus 10, and then 10 minus 10 plus 5x. What shall we get? What will be our next level? We shall say 60 minus 10 to be equal to 50, and that will be equal to, we remain this side with only 5x. So what do we do next? We shall divide both sides by 5. So 50 out of 5, then also 5x out of 5. Then from there, I think the calculation becomes very simple. Not so? Yes. We shall now say by 5, what do we get? 1. And then also 50 by 5, what do we get? 10. And then 5 by 5, what do we get? 1. And then also 5 by 5, what do we get? 1. By so doing, we have remained here with only x. And this side, we have 10. That means we shall have our answer as 10 equals to x. But we don't write like that. We start with the unknown, which therefore we can say that our answer is x equals to 10. But remember the units. Which units were used in the equation? Newtons. Therefore, our units will be 10 newtons. Are we together, dear candidates? Well, now, I would like to remind you that sometimes you can be given this kind of diagram, but it has two forces on either sides. So this side it can also have two, this side two forces, and this side also two forces. These ones here are forces. Now that means you will still use the same calculation, but the trick is here. Remember, the distance from here up to here, the pivot, is got by adding this distance and this distance. Are we together, dear candidates? Well, let us look at these questions that I am giving us an exercise. Yes, activity. Find the value of x in the given illustrations. Well, you can find that this side there are two forces and this side there are two forces. So you know how to calculate that. You will get this times this plus this times. Actually, you first come from here. This in brackets, this plus this. And then this one times this. To be equal to this times this plus x. Then you open brackets 4 plus 2 meters, okay? The same thing happens here, and I believe you will be able to calculate that very well. Dear candidates, I want to thank you for learning science with me, and I want to ask you to remain good children, behave very well, be calm, do everything, do the activities we give you, be helpful to your parents, and also keep yourself safe, free from coronavirus. I thank you. I remain Teacher Johnny Korat. Until we meet next time.